What is blockchain and why so much of hype? What if I say the next big thing in the industry is blockchain? As internet has affected all major industries in the same way, blockchain will also be affecting it. And that's for sure. Maybe in the next 2 years or 3 years or maybe 5 years, blockchain will be there. But what is blockchain and why it is so important? So let's get started. Welcome back, aliens. My name is Navin Reddy and let's get started with blockchain. If you have heard about bitcoins, you might have heard about blockchain as well. So the work on Bitcoin started in 2008 by a pseudonym. It may be one person, or it may be a group of people, and the pseudonym is Satoshi Nakamoto. So that person, or you can say pseudonym, has created Bitcoins with blockchain. So the technology behind Bitcoins is blockchain. But what exactly blockchain gives you? Now, if you talk about Bitcoins, it is basically a digital currency, right? And it works on peer-to-peer network, which is, or you can also call it as a distributed systems. So there's no central system. Example, when you want to transfer money now, you have a bank in between. But in Bitcoins, you don't have any central bank, right? Everything is distributed. So when you talk about distributed, there's one problem. The first problem is security, and the second problem is trust. How can you trust this technology? And how about security? Now there's one solution for security. We can use cryptography, right? So we can use a concept of asymmetric cryptography and we can achieve security. But how about trust? How can you trust someone that you are sending data to, or you're sending money to? Or how can you trust the data which is available on the internet? Because when you say on the entire internet, if one person is transferring the money to other person, who is maintaining the database? That's a big issue, right? Because let's say if I transfer 5 bitcoins to you, how can you ensure that you have 5 bitcoins I have and I don't have those 5 bitcoins which I've sent you? Who is maintaining the system? So that's where this ledger comes into picture. Now what is that ledger? Will it be a normal database? Now think about it. What we can do is, we can have a central database. Oh, that's a problem now because we are talking about distributed systems, right? And in distributed, why you need something in central? Okay, so that's one problem. So what if every node, or what's node here? So let's say if there are 5 people working with Bitcoins, or if you have 5 people in this network, every machine will be called as node. So can we maintain the ledger on every machine? We can do that, but how can you trust them? Because there's one problem. If you have a ledger there, anyone can tamper it with, right? Now, if you're getting confused with the ledger, imagine a simple database, or you can imagine a simple file, Excel file, or any file, let's say a TXT file. Because if you have a TXT file, anyone can change the data. Okay, think about this. Let's say if you talk about government, okay, so let's say in government we have a lot of corruptions, right? And everyone wants to stop corruptions. And the one way to do that is look at the database. So whatever they have worked on, everything will be stored in a database, right? So what if we as normal people can see that database? We can do that, but they have the power to change database, right? They can change the history of that database. Okay, so we want something where it should not be changed. So we want a ledger which will be available on every machine, but no one should be able to change it. And that's where blockchain comes into picture. So once you save data on blockchain, no one can change it. And even if someone changes it, you will know that something has changed. But how? So let's try to understand this concept. So what happens in blockchain is we have list of blocks. Okay, so let's talk about one block. So if we talk about Bitcoins, in Bitcoins we do a lot of transactions. All this transaction will become one block. That's a Bitcoin, right? Can we use this concept anywhere else? Yes, we can. We can also use this data for your personal information. We can use this block for your Facebook data, right? We can store anything, literally anything on this block. But for Bitcoins, we store transactions, right? So for different purpose, we can use this block. We can use this for Bitcoins. We can use this for hospitals. We can use this for government information. Everything will be stored inside this block. Okay, now what I'm saying is you cannot change this block, but can we? We can change the block, right? Because if you have a block, anyone can change it. But that's not how Bitcoin works. So what Bitcoins do is they use a concept of hashing. What is hashing now? So hashing means we use different algorithms to generate a simple hash key. Now it can be any algorithm we can use. We have MD5, we have SHA. In SHA also we have different length SHA. So what we can do is we can use this algorithm on a specific input. Let's say the input is my name is Navin Reddy. So if this is the input, you can perform the operation which will give you a key. Now the awesome thing is, it doesn't matter how big your input is. It can be a simple line as my name is Naveen Reddy, or it can be an entire Wikipedia database. So even if you pick the entire Wikipedia database and if you apply the algorithm, you will get a key length which is dependent upon what you use. Example, if you're using SHA-256 algorithm, you will be getting the same length key which is 256 bits. So even if I apply a key on Naveen Reddy, you will get the same length key, but the key will be different, okay? For every data, you will be getting different keys. And that's the part of hashing, because if you perform the hash on one input, it will give you the output which is different from all different data. So if you have two different data, you will not be having same hash. Sometimes we do have it, and that's why we say hash collision, but then that's a very rare case. So normally if you apply hashing on different data, you will get different keys. But how that is useful? The important thing is, if you have, let's say if I have a text which is my name is Naveen Reddy, and for that if I'm getting this key, if I change even one letter in my name, so example, if I say my name is Naveen Reddy, where I'm changing that I to double E, normally people do that for me with double E there, the moment you make a small change, then it will affect your key as well. So even if you change something in that data, it will change the key as well. So you can imagine your key as your fingerprint, right? And your data is yourself. So you are data, and this is your hash key. And the advantage is, the moment you change something from that body or something from the data, it will affect the hash as well. So how do we know if someone has tampered your data? Just check the key, right? Because if key is different, of course there's been some change in your data. But how that is useful in blockchain? So what we do is, remember that block? So we have a block. So what we'll do is, once you got this block here, you will apply hash. So let's say for block A, we have a hash, something hash there. And then let's say you have a next block now. The next block will have the data, of course, plus it will also have a key of the previous block or the hash of the previous block. So let's say the block A, and then we have a key, let's say K1. Then the second block B will have K1. Which means if you find a key or the hash of this block now, it's a combination of the data and the previous key. So now you will get K2. So for A we got K1, for B we got K2. And now let's say we have third block, which is C, you will have K3. Remember linked list here? So we have in linked list, what we do is one node. So the second node knows about the previous node, or previous node next knows about the next node, right? So that's how we create chain. So what we have is, we have a number of blocks, and all these blocks are connected with a chain. And that's why we say this is called as basically a block chain, because we have a lot of blocks and they're connected with the help of hash value. But you will say, that's simple, right? But how can you make sure that there's a trust involved here and no one can change it? Now think about this. If you change data if you change, let's say block B, the thing is, the moment you change one bit, okay, even if a small change in B, it will affect the key, right? And in block C, we have a key of B. And now when you compare the block of B and this block and the key available in block C is different. That means someone has tampered with your data. Now you know that someone has done some changes. That's why we say blockchain is safe. Now, if you will be amazed to know that till this point, no one was able to crack the blockchain database. It's that powerful. Yes, there has been some hacking on Bitcoins, but that's not on blockchain. That's the wallet which you use. So hack was done on the wallet, not on the blockchain. So it is secure, it is safe, and you can trust it. Now it is only for Bitcoin, not exactly. You can use blockchain everywhere. So in future, for government, hospitals, personal identity, Bitcoins, everywhere you will be using blockchain. And there are some banks in India as well, they have started using blockchain. And most of the industries which I have talked to, they are doing POC, which is proof of concept, on blockchains. If it is flexible for them to use blockchain, they will be implementing it soon. So there are a lot of jobs available in blockchain for sure in future. So if you want to learn something new now, start with blockchain. So I hope you got some ideas about blockchain from this video. Everyone is talking about blockchain. It doesn't matter which industry you work for, all of them are trying to implement blockchain. Some of them are still doing POC and some of them are actually implementing it. In fact, last year when I was talking to some of the companies, they were doing POC and now they are implementing it. Look at the speed now. And that's why everyone wants to get into this technology world. Now, blockchain is a cutting-edge technology which is changing a lot of stuff, right? It is replacing the old way of working and then implementing a new way. Now, there are three questions which we want to answer in this video. The first one is why blockchain? Why it is so famous? In fact, we already have a video on blockchain. What is blockchain? How it works? If you have not seen that video, check the description area. In this video, we'll talk about why it is so famous. Second question we want to answer is who can get into blockchain technology? Because some people feel they have to be into the technical field to get into blockchain. Let's see how that works. The third question is what are the prerequisites? Welcome back everyone, my name is Reddy and let's get started. So the first question, why blockchain? Now, first of all, there are certain issues with the current technology which you're working with. Example, let's say the internet which we are using now, it's amazing technology, right? It has changed the way business work. It has created different types of domains of businesses, right? Think about Google, Facebook, Amazon, they are all running because of this feature of internet, right? Now, internet was meant to be open to everyone, but now the internet is actually controlled by a few companies. And we don't want that. We don't want to have central power because it is good as of now, but what about the future? The second issue is when you do online transaction, let's say bank transaction. So if you want to send money to someone, we need a bank in between. That's not an issue with me, that's fine. So if I want to transfer money to someone else and this bank says, hey, first you have to link it from my side, that's fine with me. But the amount of fees they are charging for each transaction is something which I'm concerned about. Example, even if you do PayPal, they charge you around 4% per transaction. We don't want that, right? We don't want a central server. So that's one issue, right? We have money issue. The second one is the time. So even if I do international transaction, it does take some days or hours, right? We don't want to wait for such time. We want it to be fast, right? And that's why blockchain says, hey, you can use our way of doing it, which is decentralized applications. You can implement everything in a decentralized way. You don't want something in between. You don't want a central server. But then we have one issue here. We could have implemented decentralization way before, right? Because it's not a new term, it's a very old term. Initially, the problem was, even if you implement everything in decentralized way, can you trust someone else? Example, let's say if I want to transfer money to someone else and if I've transferred it, what if someday that guy says, hey, you have not done that transaction? How can you trust other parties? And that's where blockchain also provides you trust, okay? Because everything you do online will be saved in one ledger. Again, we'll talk about that later in detail. So everything will be stored in one ledger and that ledger will be transparent so anyone can see the transactions. And that's where if you have a transparency, you can actually trust the system. The next thing is the moment we talk about that ledger, no one can change it. So the ledger which we create, okay, so a ledger is basically a database, okay? Imagine a big database. If you have a ledger there and if you are storing a lot of transactions, we don't want it to be changed, right? We want our transaction to be saved in the same way for a longer time and it should not be changed. So we want it to be immutable and blockchain does provide that. See how exactly all this thing works, that we'll see later, but then it provides you a feature of decentralization, it provides you a feature of trust, and then it provides you a feature of immutability. Okay, the next question would be, is it secure? Of course, the entire blockchain system works on cryptography. So yes, the base itself is safe, right? So you can trust blockchain that it is safe. So these are the reasons why blockchain is famous, because it provides you all these features and it is amazing, okay? So every industry wants to implement blockchain just because of these features. The second question is, who should get into blockchain? Do we need a technical background for that? Not exactly. See, blockchain is very new in the industry, right? So yes, we need technical people who can actually work on blockchain, who can build blockchain applications. We also need people who will act as an advisor. Now, these people are more towards business. So they have a business mindset. They understand business. They understand how we can implement something for a particular application. If you understand how blockchain works, if you understand what are the use cases we can work on blockchain, you can be an advisor. So yes, we have a blockchain developer who needs a technical skills. We also have a blockchain advisor where you can consult companies. And then we have blockchain expert who are more towards architect, right? Who can actually design everything from start to end. So yes, we have different options, but then if you don't have a technical knowledge, if you don't have a technical skills, example, if you are not good with programming, if you have not done networking before or not cryptography, that's fine. You can still understand blockchain and you can be an advisor. And the third question, which is very important, the prerequisites. What are the prerequisites for blockchain? Think about this. It doesn't matter what type of course you do. Example, if you want to get into machine learning, if you want to get into full stack development, we need to have some sort of prerequisites, right? Example, for machine learning, you should be good with maths and some other concepts. And on the other hand, if you want to be into full stack, so you should be doing about designing and other stuff, right? And then how exactly server works and different stuff. What about blockchain? And yes, some courses do say you don't need certain knowledge to get into blockchain. And the answer is yes, you can directly learn blockchain from start. And we will try to do that in this course as well. We don't expect you to have any base knowledge to learn blockchain. But there's a twist here. The twist is blockchain will be easy or difficult for you is depend upon what you know already. Example, when I was learning blockchain for the first time, I was quite comfortable for several reasons. One, I loved this technology, and when you love something, you feel comfortable. Second reason is the topic which is there in blockchain, example, cryptography, distributed computing. Because I used to take lectures on this, I have made some projects based on these applications. So I'm quite comfortable on cryptography, I'm quite comfortable on distributed computing. And that's where blockchain just clicked. And that's what I'm expecting from your side. If you know something from the base, and it will be always helpful. So example, if you know cryptography, and if I'm talking about some cryptography concepts there, you will feel comfortable. And that's why the prerequisites are cryptography and distributed computing. And yes, we have some more topics as well. Example, game theory. Yes, you can learn them by yourself. Just go to Google today and start learning about them. Start searching about cryptography. Start searching about distributed computing and also game theory. The good news for you is, even before touching the blockchain technology, we will be focusing on these basic concepts, okay? So the next video we are going to implement will be on the prerequisites. So if you don't know anything, that's fine. You can start from today, or you can wait for the next video where we start with the actual prerequisites, and then we will be touching blockchain. So I hope you are excited. So blockchain, anyone can learn it, and it's a new technology, right? We don't have many people in the industry. It's booming like anything, right? As per research, in next year, we will be having more vacancies for blockchain developer than any other field. So yes, it is booming, so you can be a part of it, and we will learn blockchain together. So I hope you're excited. I'm excited. So meet you in the next video. In this video, we will talk about cryptography. The blockchain works on peer-to-peer network, which simply means you have multiple nodes and we don't need a central server. Whatever we do nowadays is based on some server, right? Example, if you are working on Facebook and if you want to communicate with your friend, we have a Facebook server in between. Same goes for transaction. If you want to send money to someone, we need a bank in between. On the other hand, when you talk about peer-to-peer, we don't need a central server. This is not something which is very new. It's there from a long time. If you remember Napster, it was built on peer-to-peer network, which simply means you have multiple nodes or people, they want to share music for free, of course the pirated one, and they can do it using peer-to-peer. Example, let's say if you have 4 people here, or 4 nodes, A, B, C, and D, and if A and B, they have a music album with them, the same music album, and if C wants the same album, he can download from A and B at the same time. So maybe half album from A, half album from B, and at the same time, C can also upload the album so that D can download it. And that's how peer-to-peer works. We don't need a central server in between. Torrent also works on peer-to-peer network. If you have ever used Torrent, you know what I'm talking about, right? We have seeds, we have peers. So P2P is awesome. But it doesn't matter what type of network you work with, we have 4 big concerns. The first concern is confidentiality. The second one is integrity. Third one is non-repudiation. And the fourth one is authentication. So let's talk about the first one, which is confidentiality. So let's say if you are working on this peer-to-peer network, and if you have, let's say, A and B, we also have C and D. Let's talk about them later. So we have A and B. Let's say A want to send a message to B. Now this message can be anything. It can be a simple message, let's say hi, hello, or it can be very confidential, let's say your bank details. And if you are sharing those details on the network, and which is open, it can be accessed by anyone, right? Let's say we have C in between, and C says, hey, A is sending a message to B, and C can actually read it. That's something which we don't want, right? We want our data to be confidential. It can be a simple data or a very secret, but everything should be confidential. So that's one thing we want to achieve. The next thing we want to achieve is integrity. So let's say if A is sending a message to B, and of course we don't want anyone to see that message. But let's say it's a very simple message, and the message is, hey, let's meet at 6 p.m. Now, if someone else is able to see that message, that's fine with me. But let's say C comes in between and say, hey, I have read the message, okay, but then I also want to modify it. C modifies the data by saying, hey, let's meet at 5 p.m. That's where the problem starts, right? Someone in between is changing my data. So the data which is received by B is different from what A is sending, and that's where we have an issue of integrity. We don't want our data to be modified on the network. The third one is non-repudiation, which simply means no one should say that you have not done that or I have not done that. Example, let's say if A sends a message to B as by saying, hey, let's meet at 6 p.m. And let's say if B showed up and A is not there, after some time A will say, hey, I have not sent you any of that message. So we don't want that. If A is sending a message to B, there should be a proof that A has actually sent the message. So that's about non-repudiation. The fourth one is authentication. So let's say B has received a packet, and the packet or the message is, let's meet at 6 p.m. and the message is sent by A. What is the guarantee that A has actually sent the message? It can be C as well. So maybe C has sent the message in the name of A or maybe some other identity, and that's where the problem starts, right? We don't want anyone else to send a message on someone else's behalf, and that's where we have an issue of authentication. So how do you solve this 4 problem? And that's where we have a concept of cryptography. Now if you talk about this term cryptography, it's basically had 2 terms. The first one is crypt and second one is graphy. So crypt is basically means hidden or secret, and graphy is basically writing. So that means when you send a message, you have to convert your message in such a way that someone else will not be able to read it. Now when I say someone else, it should be readable only by the receiver but not by anyone else. How do we do that? So what we do basically here is we use a concept of encryption and decryption. Now what it means, so let's say if you have A and B, if A want to send a message, so that message will be first encrypted and we will get something new known as a ciphertext. Now ciphertext is basically an unreadable format, and then this unreadable format, ciphertext, will go to the receiver end, let's say B. Now B will be able to see that, but unfortunately the moment you encrypt a message, you can read it only when you are decrypting it. That means if you want to read the message, you have to decrypt it. How will you do that? The only way to encrypt and decrypt something is with the help of a key. So if A and B has a key, they can encrypt and they can decrypt. No one else can do that because they don't have a key with them. So based on these keys, we have 2 different types of cryptography. The first one is symmetric key cryptography. The second one is asymmetric key cryptography. And what are those? That we'll discuss in the next video. In this video, we'll talk about types of cryptography. So basically there are 2 types. The first one is symmetric key cryptography. The second one is asymmetric key cryptography. Now as name suggests, the first one should be having symmetric key and the second one will have 2 different keys, right? So let's start with the first one. So let's say, assume we have A and B. Now A want to send a message to B. What A will do, A will simply encrypt the message using a key. So let's say that key is K1. So using a key K1, A will encrypt a message. That message will go to B. In fact, even B cannot read that message because it is encrypted format. So B has to decrypt it. Now which key B will be using? Of course the same key, right, which is K1. So A and B both will have the same key, which is K1. Now it's a different question, how will they share this key with each other? Of course not on network, right? At the end we want them to have the same key, which is K1. So now let's say we have one more. We have A and C. So of course we have B there. So if A want to send a message to C, now what type of key A should use? Should A use K1? Of course not, right? Because B has K1. So if A want to send a message to C, or which should not be interpreted by anyone else, A will use a different key now. And let's say we will name that as K2. So between A and B we have K1. Between A and C we have K2. Let's say B and C want to interact. What key they will use? Will they use K1? Of course not. Will they use K2? Of course not. They will need a different key, which is K3. What I want to say is, as the number of user increases, we have to increase the number of keys. And it will be difficult to manage, right? Example, in my pocket, I have to carry 100 keys because if I want to interact with 100 people, I have to manage all the keys. We don't want that. So that's one of the drawbacks of symmetric. Let's move towards asymmetric. Asymmetric cryptography, also known as public key cryptography. So basically we use two different keys here. One is private key and one is public key. So what is this public key and private key? As name suggests, everyone will have two keys. Let's say A want to send a message to B, B send a message to C. So on this network we have multiple nodes. Each node will have two keys, the private key and a public key. So A will have its own private key and public key, B will have its own private key and public key, C will have its own private key and public key. If you want to encrypt and decrypt the message, you have to use both the keys, not one. So to encrypt a message, you can use public key, but to decrypt the message, you have to use private key. If you are using a private key to encrypt the message, then you have to use a public key to decrypt the message. So you have to use both the keys at the same time. You can't simply say I will encrypt with public key and decrypt with public key. That's not possible. So we have to use both. So if you are encrypting with private, you have to decrypt with public. If you are encrypting with public, you have to decrypt with private. How do you achieve security here? So let's say if A want to send a message to B. As we know, the public key of B is known to everyone. Public, right? So of course, A will also know the public key of B. So what A will do, A will encrypt the message with B's public key. And then that message goes to B. Of course, everyone else on the network can see that message, the encrypted message, but no one can decrypt it. You know why? Because that message will be decrypted only with B's private key. And who has B's private key? Of course, only B, the private, right? So you will know your private key and everyone else will know your public key. So that's how you do it. So how to achieve security? Encrypt the message with public key and decrypt the message with private key. Let's do it again. So let's say C want to send a message to D. So which public key C will use? So C will use a public key of D. So C will encrypt the message with D's public key and D will decrypt the message with its own private key. So that's how this cryptography works. But now the question is, what is that key is? Is it a number? Is it a text? That we'll discuss in a separate video. In this video, we'll talk about digital signature. Why do we need it? So let's go back to the previous video where we have talked about 4 problems on the network. The first one was confidentiality, second one was integrity, third one was non-repudiation, and fourth one is authentication. So we have talked about confidentiality, right? How do we achieve that? With the help of cryptography, of course. What we do is we use a receiver's public key to encrypt the message, and then the moment this message received at the receiver end, the receiver will decrypt the message with the help of his own private key, and that's how it works. And no one else can actually decrypt the message because no one has the receiver's private key. So that works, right? We have achieved confidentiality. What about authentication? How do we achieve that? And that's where we have a concept of digital signature. So let's imagine we have multiple nodes on this network, and one of them is A and the other one is B. And B has received a packet or a message by saying, let's meet at 6 p.m. And packet claims that this is coming from node A. And this is where the problem starts, you know. How can you be sure that this packet came from node A? And how node A can say, hey, I have sent that message. So to solve this problem, you know, in real world as well, what we do when we write a letter, we also sign the letter, right? That's your signature, which specifies that this letter has been sent by you or written by you. How can we do that in the virtual world? Of course, we cannot use a pen drive, right? And that's where we have to use a digital signature. How can we do that? So let's imagine we have 2 keys, right? So everyone will have 2 keys, a private key and a public key. If I want to send a message, so let's say A want to send a message to B, and the message is, let's meet at 6 p.m. Now, before sending that message, what if A will encrypt the message with the help of A's private key, and then this message goes to the B, and B is able to decrypt it with A's public key. But then hold on, A's public key will be available to everyone, right? That's the case. We are not trying to achieve confidentiality here. We are trying to achieve signature. The moment A is able to sign the message by his own private key and it is decrypted by A's public key on the B's end, now B is sure that this message is coming from A because this message was able to decrypt with the help of A's public key. And the only way you can do that is by if this message has been encrypted by A's private key. And now we have achieved authentication, right? But then we are losing confidentiality, right? How can we achieve that? So what we normally do is, from the A side itself, so before sending the message, A first will encrypt the message using A's private key. And then the same packet will be again encrypted with the help of B's public key. So we have double encryption. We're using B's public key and then A's private key. When B received that packet, it will first decrypt the message with the help of B's private key, and then it will again decrypt the message using A's public key. And that's done, right? Now we got a message. So we have achieved two things here, confidentiality, and second one is authentication. And that's how it works. So even if you have C in between, C cannot decrypt the message because it is encrypted with the help of a B's public key, right? And that's how we achieve signature. In this video, we'll talk about nodes. In the blockchain system, we have a concept of nodes. Now you can imagine a computer or a mobile phone on the network is known as node. In fact, the internet which we are using now, the devices which we use are nodes, right? Example, it can be router, it can be desktop, anything. So in the same way, in the blockchain network also we have a concept of nodes. Now these nodes can be again a computer or a mobile phone. Now what this node does, now based on the type of node you have, it performs different operations. Now first of all, we have two different types of nodes. The first one is full node, or you can call them as fully validated node. The second type of node we have is partial node, or you can say light nodes. So let's talk about full node first. Now full node is basically a computer which will have the entire blockchain. So the current size of blockchain is 188 GB. I'm talking about today's date, which is 28th October 2018. So it is 188 GB and every day it is increasing. So all this data will be stored on full node. This full node has one more task of verifying the node. So first it will store the entire blockchain. Second, it will verify the blocks which is getting added. So every time the connected node says, hey, we got new block now. So this full node will verify the entire blockchain. And once it verifies, then only it will store it. You know, something like, let's say, if the peer node says, hey node, we got a new block for you. Now this full node will check, okay, so you're giving me a new block, let me first verify it. After verifying it, then only it will add that block in the full node. Now in blockchain, we have one more term which is miners. Now miners are basically mine the blocks. Now again, how that works, that we'll discuss later. We have a concept of transactions. The transaction goes into a block, miners will mine it. We'll talk about that later. A full node can also be a miner. Basically, if a full node, a computer, runs a mining software, then we can call them as miner as well. It's not compulsion that a full node should be miner as well. Okay, so we have two different things, a full node, and then we can have a full node with a miner. The only thing is, when we talk about full node, we only need a huge amount of storage, which is approximately 188 GB as per now. But if you want to be a miner, that's where you need a huge computing power. Now when I say huge computing power, I'm talking about stack of CPUs and huge amount of GPUs. So miners, they use CPUs and GPUs as well. You can try those things with your laptop, but then you can never mine with your laptop because it has a very low power. You need a huge amount of power. And to run that machine, you need electricity as well. So that's a huge investment. So for the full node, you don't need a huge investment. You can use your normal computer, provided you have 200 GB free now. But then if you want to be a miner, you need a huge amount of CPU and GPU power. Basically, you need an entire center with CPUs and GPUs, so investment, right? But then as a miner, you earn incentives as well. So basically we have incentive model. So every time you mine a new block, you do earn the transaction fee and then some Bitcoins as well. Again, that's only specific to Bitcoin, but again, we'll talk about that later. But full node, as a full node, you don't earn, but then you can be a miner to earn because they're investing a lot of money. On the other hand, we have a concept of partial nodes or light nodes. Example, let's say if you want to use Bitcoin, if you want to use any wallet, and if you want to do that on your mobile phone, of course, your mobile phones need to have that software. Now, of course, this will also be a node now. The moment you install software, this becomes a node, but then this will be a partial node because I cannot simply download the entire blockchain on this phone. So this will have some part of blockchain so that it can run, so that it can send money to someone else. That's your light node, or you can say partial node. So we have a concept of full node who will verify the transactions, who will store the entire blockchain. And then we have partial nodes who can they use it for valid purpose. So that's about nodes. Again, we'll talk about in detail how exactly miner works, how exactly we create blocks. Just to get the idea of nodes, this is what nodes are. And let's continue with this series on blockchain. And we are talking about the prerequisites for blockchain, and one of them is hashing. So in this video, we'll talk about those terms like hashing, hash function, hash value. So let's get started. So basically, hash function is a mathematical function which takes arbitrary length of numerical data and convert that into a fixed length numerical data. As I mentioned, the input will be of any length. It can be a smaller value, it can be a big length value, but the output will be of fixed size. Now, based on the algorithm which we are using to do that, the output length will change. Example, we have a concept of message digest, we have a concept of SHA. So based on what type of algorithm we use, we will be getting a different set or different length of hash value. But your input can be of any type. It can range from 1 bit to thousands of millions of bits. And that's the amazing part, you know. So even if you are passing a huge chunk of data, let's say 5 GB of data as an input, you will get a fixed length size. Example, let's say if you take my name there. So my name is Navin Reddy. So if I type that text, you will get hash value. It's going in a function and that function returns you this value. The amazing thing is, if I use a certain algorithm, let's say if I'm using SHA-256, and if I type my name there, if I say my name is Navin Reddy, doesn't matter at what point I do that, doesn't matter how many times I do that, I will get the same hash value. That means for same input, we will be getting the same hash value every time. The next amazing thing we have is, even if you have a small change in your text, it will change your hash value in a very different way. You can see even if I change my Reddy from small r to capital R, you can see the change now. It is changing the entire hash value. It's not that someone can guess now, right? It's a very different thing. The third amazing thing is, you cannot get the actual input from the hash value. That means the reverse is not possible. Of course, we convert the given data into hash, which is very easy to do, but it is very difficult. In fact, it's almost impossible to go back. And just to remind you, hashing is not encryption, because in encryption we can get the data back using decryption, but that's not the case with hash, because in hash, once you get the hash value, you cannot get the data back. Of course, right? How will you get it? Because when you do hashing, you will lose a lot of data. Let's say even if you have your input as in GBs, the output will be in bits, right? So of course, you are losing a lot of your data. So it's impossible to get your data back. One more important thing is, for two different messages, you will be having two different hash values. You will never get the same hash value. If that happens, we will call them as collision. Now you might be asking, okay, this is a theory, right? How do we implement that? Now, first of all, in blockchain, we use them, okay? So when we implement blockchain, we will be using different algorithms. We will not be writing those algorithms by ourselves. If you want to know more about the algorithm, you can just check out some other videos, or I will try to make a separate video on explaining how exactly to create that algorithm. But as of now, what we are doing is we are taking the input and we are getting the output. We will be using this output, we'll be using this hash value in the blockchain. So there are different algorithms available. You can try them out. So one of them is MD, which is message digest, and there are different versions of it. We have MD2, MD3, and then latest version is MD6. There's also MD5, but few years back there was an attack on MD5 and it was compromised. So that's why people are not using MD5 now. So now they are moving towards SHA, which is Secure Hash Algorithm, which is built by NSA. So again, we have different versions for it. We have SHA-0, SHA-1, SHA-2, and now we have SHA-3. In blockchain, we normally use SHA-2. In SHA-2 as well, it's a family actually, and we have different versions of it. The two popular versions we have is SHA-256 and SHA-512. These numbers actually represent the output bit values. Example, if I say SHA-256, it will be having output as 256 bits. Now if you say 512, of course it will be having output as a 512 bits. But how exactly you will be using hash in blockchain, that's a different concept. So once we start with blockchain, you will understand how exactly we can use hash there. But again, hashing is basically a very important concept. So let's take another example for hashing, which is not related to blockchain. So let's say if you want to download Ubuntu. Now of course you can just go to Google, search for Ubuntu, download, and you can get it. So it will take you to the official website of it, and from where you can download the file of around 1 GB. And it will work, right? You will get the file. But what if you want to download it from torrent? Because it gives you that feature, right? It gives you multiple peers, you can download it from multiple places. So of course, even I prefer to download it from uTorrent instead of going to the official website. But there is one risk. What if the setup which you are downloading from torrent, it can be malicious, right? So someone else have uploaded that setup and you're downloading it, and which will be having some viruses or some malware, right? So how do you verify the setup which we are downloading is official? So what we can do is, on the official website, they have a setup, plus they also have a hash value. Of course, we are not downloading the setup from the official website, but we can get the hash value, you can copy it. Now, once you get the setup from the torrent, you can generate the hash value for the particular setup. So let's say the setup is of 1 GB, you can use certain softwares which will give you the hash value of that setup. And then you can compare. If the hash value of the generated one and the hash value from the website is same, that means the setup is official. Because even if some hacker has changed 1 or 2 bits, it will change the entire hash value, right? So of course, that's how you can verify. So yes, we can use hash value in multiple places, of course, in terms of security, but then we can use that in blockchain as well. Again, how to use it, that we'll see later. In this video, we'll talk about Merkle tree. Now, when it comes to blockchain, we have a lot of blocks, and then these blocks will be connected with the help of hash value. Again, how exactly that works, that's a different thing. Every block will have transactions. Now, this can be one transaction or thousands of transactions. And then we also want to find a hash of the block, right? So what do you think? Will you just combine the entire block and find one hash? Or will you find the hash of each transaction? Now, if you want to find the hash of each transaction, you have to store all the hashes, right? So one block will not have one hash. One block will have thousands of hash. We don't want that. We want to get only one hash. One of the ways to implement that is with the help of Merkle tree. Now, first of all, we'll try to create a tree here. Now, when you look at a tree will have a root, a tree will have leaves, and a tree will have nodes. So the end nodes, they are normally called as leaves. The nodes which has these leaf nodes, or the nodes in between, they will be called branches, and then on the top we have root. So how do you build this tree? So let's imagine in one block we have 10 transactions. Now you will start calculating the hash of each transaction. So let's say for 10 transactions you got 10 hash value. Now what you will do, so you will find the hash value of first and second. Then you will find the hash value of third and fourth, and the list goes on. So you will find the hash of all this. Now once you got the hash of 1 and 2, you got the hash of 3 and 4, you got the hash of 5 and 6, and list goes on. Again, you will combine the hash of 1, 2, and 3, 4, right? You will get the hash of 1, 2, 3, 4. And then at the end, you will combine everything to get a hash of 1 to 10. That's how you do it. That's how you build this tree. So in this example, you can see the end is of even number, right? You got 10 transactions. But what if you have odd number? Because normally when you talk about Merkle tree, it's actually a binary tree. So in binary tree, you need to have even numbers of nodes. So at the end, if you have, let's say, 9 transactions, at the end, you will just repeat the transaction. So you will say 9, 9 repeated, right? That's what you do. So at the end, when you combine all these things, on the top, you will get hash. That's a hash of the Merkle root. And that's how you find one hash of the entire block. Now this is very useful when it comes to blockchain. Again, once you start with blockchain, you will see how that works. So that's the basic idea about Merkle tree. And in this video, we'll talk about blockchain architecture. So we have talked about the basics of it, right? We have talked about hashing, we have talked about Merkle tree. Now we know the prerequisites for blockchain. In this video, let's focus on the architecture of it. Now when I say architecture, I'm talking about what exactly blockchain means and what is that inside each block. So let's start with it. Now blockchain is simply a database, right? Of course, a lot of people have a lot of expectation from blockchain. They feel blockchain can solve all the issues. Not exactly. Blockchain will solve issue based on data, right? So the issue nowadays we have is we can manipulate data, and plus we also want to make sure it is distributed. And that's what we can achieve with blockchain. When you say a block in blockchain, you have data. So now what kind of data I'm talking about? Now as blockchain type changes, we have different types of blockchain, which we'll talk about that later in detail. But the moment you talk about different blockchain, they will have different set of data. Now one of the blockchain which is very famous is public blockchain, in which the example is Bitcoin, right? The first blockchain implementation. Now the Bitcoin block will have what? Now we use Bitcoin to send money, right? So of course it will have from, it will have to, and the money as well. Now that is the data which you save in a block. Now with this data, you have one more thing which is known as the block header. Now why do we need a block header? The thing is, you will be having a lot of blocks, right? So how can you differentiate between each block? And how can you create that chain which I'm talking about? And that's where the block header comes into picture. So what this block header will have? First thing we need is every block need a timestamp, right? That's important, right? If you don't have a timestamp, how do you know at what point or when this block was created? So we need a timestamp. The second thing we need is a version, right? Now we have different versions of blockchain or the protocol which we use. So that's one thing you will have. So you will have a timestamp, you will have a version, and then we'll also have a Merkle tree. Now if you remember, we have talked about Merkle tree, right? So in one particular block, you'll be having a lot of transactions, and then you need only one hash of it. And that's where we will need a Merkle root. So we need a timestamp, we need a version, and a Merkle root. Now what else? Now we need two more things. The moment you talk about public blockchain, one of the algorithms which is very famous is proof of work. Again, we'll talk about that later. But then if you want to verify the block, we have to use POW, which is proof of work. And to make it work, we need two more fields. First one is the difficulty target, and second one is nouns. So we'll talk about that later once we talk about the proof of work. But as of now, we need these two fields as well. Now we have talked about 5 fields. So in a block, you'll be having this 5, but we'll have one more, and that is your previous hash. Now what a hash I'm talking about, every block will have a hash, right? How will you create this chain? Every block will have the hash of the previous block. So example, let's say if you have 5 blocks now, so second block will have the hash of the first block, the third block will have the hash of second block, the fourth block will have the hash of third block, and that's how you create a chain, right? You can track backwards, right? So let's say if you are on 55th block, now if you want to know the previous block, of course you have to follow that chain, right? You have the hash of previous blocks with you. Now the question is, what is the advantage of it? If you remember, when we talked about blockchain, we talked about immutability, right? Which simply means once you create a block in a blockchain, no one can change it. Okay, when I say no one can change it, is it password protected or something? What if I say blockchain is open, anyone can manipulate data from blockchain, okay? But why people say it is secure? So let's think about it. Now when you talk about hash, every time you change a data, it will change the hash value as well. So example, let's say if you have these 5 blocks, and then the hash of 4th block is in 5th block, right? The hash of 3rd block is in 4th block. The moment you change any block, let's say I want to change the 2nd block here. In that case, what will happen is the moment you change the data of the 2nd block, it will change the hash as well, right? Now the hash is changing, right? Now it will affect the 3rd block because you have changed the hash value. And that's where the problem starts. Because if you change 2nd one, it will change the hash and then it will affect 3rd one. And now again, you have to regenerate the hash for 3rd one to make it work, right? And that's where it will affect the 4th one. Again, you have to do the same thing for 4th, and it will affect the 5th one. Now the number of blocks which we have in blockchain is huge. So of course, if you change any one block, you have to change all of those. Is it difficult? Of course not, right? We are living in a world of supercomputer. So what we can do, we can collect thousands of devices with us, and you can change the hash of each block. It's not that impossible. But then how can you make it secure now? That's where the concept of POW comes into picture. So every time you change something in a blockchain, or if you want to add a new block, it has to be validated. I'm talking about the public blockchain now. So without validation, you cannot add a block. That means you have to do some processing to add a block. And that's where we have a concept of PWO, which says it will take at least 10 minutes for anyone to add a block in a blockchain. Now when you say even if you change one block, and if you have 5 blocks, you have to wait for 50 minutes to change the entire block. Okay, that's one thing. It will take a lot of time. Second, your blockchain will not be stored in one machine. It will be there with multiple people. Anyone can be a part of blockchain network. It's not just a central server. So example, let's say in this network, if you have 10 people, everyone will have their own copy of blockchain. Of course, it is a full node. We have talked about that before. So if you have 10 people, when you add a new block in a blockchain, it has to be verified by everyone, right? So everyone will come in consensus to add that block in a blockchain. And that's where we have a concept of consensus algorithm to add data in a blockchain. And that's where you are making your blockchain secure. So first of all, you need a supercomputer to change the block, and you have to wait a lot of time. Plus, even if you want to do that, you need a 50% majority in the blockchain network, which is almost impossible to achieve, right? Because to process that POW, you need a huge amount of GPUs and CPUs. You can't be that rich to have the hold of 50% of the blockchain network in the world, right? And that's how you make blockchain secure. Now there's one more question. Every block will have the hash of previous blocks. So 5th block will have the hash of 4th, 4th will have a hash of 3rd. What about the first block? Now the first block is known as a Genesis block. Now Genesis block previous hash value will be 0, right? Because we don't have any block before that. In terms of Bitcoin, it was created by Satoshi Nakamoto, the Genesis block, and then based on that block we got new blocks. So that's something you remember. So that's it. That's about the block structure in the blockchain architecture. In this video we'll talk about types of blockchain. Blockchain came into existence for Bitcoin, right? So they wanted to implement Bitcoin and they wanted to make it secure, and that's where we have blockchain, right? On the other hand, the industries, they looked at blockchain and they thought we can implement this technology in our areas. So whatever problem we are facing, can we use blockchain there? So initially when you talk about blockchain, it was majorly for cryptocurrencies. We had Bitcoin and then we came up with Ethereum, and then there are a lot of coins available, right? So we have alternate coins as well, and somewhere they were very happy with blockchain. But what about finance industry? What if you talk about education industry? How they can use blockchain? Now one of the issue with blockchain is some people say it's not secure because all the transactions are open. Yes, they are anonymous. We don't know who is sending what money to which address, but still you can see this stuff online because all the data of Bitcoin blockchain is available openly. That's why it is named as the public blockchain. It is open, plus anyone can be a part of this network. So let's say we have 10 nodes which is working on blockchain, and now if you want to be a part of it, you can do that. You can have your own node and you can be a part of that open blockchain. Of course, you can be a miner or you can just be a local node, but then you are able to join that public network. So that's the issue which other companies don't want. They want to have their own blockchain. Is it possible? And yes, that's why we have the next type of blockchain, which is private. So private blockchain is especially for one company. Let's say if I feel, hey, this is my finance industry or this is my company which works with client data or money. I don't want this data to be shared with anyone else. I want to have my private blockchain. I don't want anyone else to contribute. So the number of nodes who will be validating my blockchain and the number of nodes who will be adding the blocks in my blockchain will be controlled and will be knowing about everyone. And that's where we have this private blockchain. The next one we have is federated blockchain. Now this is where you'll be having group of people or group of companies. They will be coming together to create a separate blockchain, and of course there will be someone who will be leading it, but then it will be group of people and you will be knowing everyone in the group. So let's say if you want to add a new block, you will be the known entity. It's not like a public ledger or public blockchain where anyone can be a part of that network, right? So basically we have three. We have public, which is open to the entire world. You can be a part of that network. Second, we have private, which is only limited to one company, or they might want to add the transactions privately, but it will be having only write access. Maybe you can allow public to read the data, but then the writing will be restricted. On the other hand, we have federated, where you have group of companies working together. Again, we have one more, which is permissioned or permissionless blockchain. We'll talk about that later, but these are the three types. Now the question arises, which is the best one? Is it public, private, or federation? Of course, right, public is best because anyone can be a part of it. Now since we are using proof of work, which takes 10 minutes for each block, so it is slow. On the other hand, when you talk about private or federated, it's fast because we don't have to use POW because all the entities here are known. There is one concept which is very famous in the blockchain world: consensus. So what is consensus? So let's say we have 5 mining nodes here. Now all these nodes will be having a copy of a blockchain, and all the copy will be of same state. So they are the exact copies here. Now what if you got a new block? So yeah, we have done some transactions and you got a new block here. Now this block is supposed to be added in a blockchain. But then which mining node will do it? Of course, if you say, hey, let's give it to the latest mining node, let's say mining node 5, and node 5 will add that in its own blockchain, and with the help of the protocol, we can just replicate in all the blockchains here, in different nodes. But there's a problem here. What if node 5 is malicious? So how you make sure that all the nodes come to the consensus and they will have the same copy of it? And that's where we have to follow some consensus algorithm. Now in the blockchain world, we have so many consensus algorithms, so using which you can actually agree on one particular state of a blockchain. So if the new block is added in a blockchain, who will add it, that can be defined with the help of consensus. Now based on it is permissionless or permissioned blockchain, we have different consensus algorithm available. The first one, which is proof of work, which is very famous thanks to Bitcoin. So Bitcoin uses POW to achieve the consensus. Right now, what is POW in short? Let's say we have all the nodes here. Now all this node will spend some computing power doing some calculation, and whoever wins the calculation or whoever wins the puzzle, they will add this block in a blockchain. Yes, they will receive some bitcoins, and that's a different concept, right? But in POW, we have to make sure that the node, before adding the data in a blockchain, is doing some computation, and that's how we can understand, yes, they have spent some computing power, so we can trust them. That's the POW part. We have some more. In fact, we have POS in the Ethereum world. Now POS stands for proof of stake. But why we need POS when you have POW there? There is one issue with POW. We have to spend huge amount of computing power. Don't you think we are already short of resources available, and you are spending huge amount of resources, the power resources, on the blockchain? So in proof of stake, you don't actually do a lot of computation. It's more about stake. So let's say if you are a miner and if you want to add that block in a blockchain, of course, in a Bitcoin network or in a Ethereum network, you will receive some Bitcoins or some currency when you win it, right? But then before applying for that or before going into that blockchain, you will be putting some stake in that blockchain. Now, when you say you have a stake in that, let's say I'm spending, let's say, 5 cryptocurrency of some type, maybe Bitcoins or some other coins. So I'm saying I'll be investing 5 coins there. But you might be thinking, okay, what's a big issue? Anyone can invest. No, if I'm malicious, I will not do that, right? Because if I'm malicious, if I do something wrong, they will kick me out of the blockchain, right? So I'm secure now. So when I say I'm spending 5 Bitcoins or 5 coins, that means you can trust me. So whoever has the highest stake, they will win the puzzle or they will win the block there. Likewise, we have so many other algorithms as well. We have POAT, which is proof of elapsed time, built by Intel. Then we have POD, which is proof of deposit. So it's almost same as stake, but here you are depositing amount before entering into the blockchain. Then we also have POC, not the proof of concept, but proof of capacity. Now here you're not actually going for the computing power, which is CPU, which consumes a lot of electricity power, but here you are consuming the hard drive space. So whoever has the huge capacity, they might win the block there. So that's the general concept of consensus. So the idea is, using consensus algorithm, we can actually agree on one particular state of a blockchain in the entire network. And in this video, we'll talk about proof of work, POW. If you remember, in the last video, we have talked about consensus and why do we need consensus in blockchain. Now, when it comes to proof of work, it's a consensus algorithm just like POS, and then we have POC as well. This is one of them. But this is famous because of one thing, Bitcoin. Now, first of all, why do we need a POW? Now think about this. When you have a blockchain, and of course in this blockchain network, you'll be having multiple nodes, and all this node will be having the same state of a blockchain. But now let's say you have a new block. Now, who is responsible to add this new block in a blockchain? First of all, we have to verify all the transaction, which is quite easy, but who will add this block in a blockchain? It's important for us that that node should not be a malicious node because it can manipulate data. We don't want that. Every node who is competing to add that block in a blockchain has to do some computing work. Now, what kind of computing work? So this is normally we say they will be given a mathematical calculation, and whoever solves that calculation will win. So when you say they will win, they can add the block in a blockchain and they will receive some coins or some rewards. Now in Bitcoin network, they will receive Bitcoins. In some other network, they will have their own rules. But the important thing is they will win and they will add this block in a blockchain. But then why do we need it? Is because if you are spending huge amount of computing power, so the chances goes down that you will be a malicious software or you will be a malicious node. The second thing is, let's say in a blockchain, if you have 30 blocks and if you want to change 25th block, it will affect the hash of all the remaining blocks, right? So I can recalculate, right? I can recalculate the hash of all the blocks. It is easy, right? Actually, no, because every time you make a change, every time you add a block in a blockchain, you have to do POW, which will take some amount of time, some amount of computing power. If you are that rich and if you have so much of time, you can do that. But hold on, the moment you are doing that, some other nodes or some other block will be generated which will be added in a blockchain. So it makes your attack useless. But we have one question here. What is that mathematical calculation? So of course, every node in a blockchain or every miner who want to compete will be solving that mathematical problem. So from video 1 to this video, we have the same question. What is that mathematical problem? Now, first of all, the complexity of that puzzle depends upon the network, the size of the network, how many users are active, and what's the blockchain size, and all the other factors. Now, this can be easy. Example, let's say if I give you a number, let's say 525, you have to find the factors of that number. Maybe I will give you some extra logic as well. You know, these two numbers should have a difference of maybe at least 50, something like that, okay? Now you will be spending your computing power to calculate that. Now this is easy, it can be done in seconds, but let's say if I make it difficult, if I talk about hash functions. So just to recap about hash, if you give input to hash function, it can be any length input, it will give you fixed size length. And the amazing part is if I give you Naveen, it will give you a unique hash. But if I change something from Naveen, if I change that capital A to small a, it will give you a very different hash value. So you can't even guess, okay? So you have to generate. So if I give you, in fact, if I give you the output of a hash and you have to guess the input, and that's where you will be doing a lot of calculations, right? Maybe I will say there's a 5-digit number and you have to find the input for this particular output. Or maybe if I give you, there's a name of 10 letters from the dictionary, you have to find it, something like that. So they have to do this computational power by brute force. You can't apply logic here. It's all brute force, right? So if you have huge computing power, you can do it easily. But if you don't have that, you may lose. And that's the mathematical equation which they do. So do we have any drawbacks of this? Yes, we have drawbacks. Don't you think we are wasting so much of energy here? We are doing so much of computation which is useless. So that's one problem. Second one is the 51% attack. So what if I have a network of 10 nodes? So let's say there's a blockchain network of 10 nodes. And out of those 10 nodes, 6 nodes are malicious. In this case, you have more than 51% of the network in your hand. So of course, this can be hacked. You can hack the blockchain network now. So that's two issues we have, but then that can be solved with some advanced things. That's POW, which is proof of work for you. So what is Ethereum? Now let's go back to Bitcoin. So when we talked about Bitcoin, we said, okay, Bitcoin is a technology which is based on blockchain. Same goes for Ethereum. But why do we need Ethereum when you have Bitcoin? Now think about this. When you say blockchain, blockchain will make internet decentralized again. Okay, when you say it was centralized because of all these big companies, whatever you do online goes through these big companies, right? We have Google, Amazon, Facebook, they are managing the entire internet now. So we want to make it decentralized and we said, okay, let's use blockchain. But the only thing which we know about blockchain was Bitcoin. But if we talk about Bitcoin, Bitcoin is only a peer-to-peer electronic cash system. So that's good. So if you want to do transactions online, we can use Bitcoin. So when you say a Bitcoin blockchain, every block will be having data, right? So all the transaction data. But what about software? Think about the current internet world. What we do, we write apps, right? We create websites, we have enterprise applications. So all these applications are running on internet, which is centralized. If you want to make it decentralized, we need a network which can run applications which are decentralized. And that's where we got Ethereum. So thanks to Vitalik Buterin, who is the inventor of Ethereum. So in Ethereum, we have this amazing concept known as EVM, which is Ethereum Virtual Machine. Okay, so if you are coming from a Java or .NET background, you know what I'm talking about, right? So to run any application, to run the software in Java, you need JVM to run, which is Java Virtual Machine. In the same way, in the Ethereum world, if you want to write softwares and if you want to run them on the Ethereum network, you need that virtual machine. Okay, so that means we have two different concepts, right? We have Bitcoin, which is more for cryptocurrencies, and then we have Ethereum, which is more for decentralized applications. In fact, in short, you can call them as dApps. Okay, but there's one question. What about the cryptocurrency in this platform? Because on this side, we have Bitcoin. So in the Ethereum platform, first of all, this is not a cryptocurrency, it's a platform. In this platform, if you want to use a cryptocurrency, we have Ether. Because if you want to run this decentralized application, we do need the cryptocurrency there, and that is Ether here. So we also have a concept of gas, which we'll talk about later. But as of now, we have Ethereum, which is a platform. Basically, it's an open software platform. So you can build your own application on Ethereum. It is damn easy to start with. So we have a special language using which you can build applications there. But then it's quite easy. So once you are familiar with Python or JavaScript, learning that language will be easier. So once you know that language, you can simply go to Ethereum network and you can build your own application. You can use the existing applications or you can build your own. You might be thinking it will be difficult. Of course not, it's damn easy to start with. Yes, but if you want to make complex projects, that's where you have to apply some logic, it will take some time. But starting with it is damn easy. So just to recap, Ethereum is a platform where you can create a decentralized applications, which is dApps in this case. So it also has its own cryptocurrency, which is Ether. So that's the basics on Ethereum. And in this video, we'll talk about smart contracts. Now, if you remember, in the last video, we have talked about Ethereum. So in Ethereum, it's a blockchain basically where you can write codes. You can write programming codes. Now, if that programming code represents any type of contract, we will call them as smart contracts. Okay, I know it's confusing, right? So just to keep it simple, let's take an example. Now, if we talk about a lot of online websites, especially e-commerce websites, so most of the websites we don't trust, right? Example, if I want to buy something online, I have some specific website in my mind. Example, in India, Amazon, Flipkart, Snapdeal are quite famous, but I don't even try other websites. Example, let's say there's a website named as abc.com where you can buy stuff online. Maybe I will not buy from them. For one reason, I don't trust them. Second reason, maybe it's not secure. So how do you build that trust and how do you make it secure? So when you say I don't trust them, what's wrong with them? So let's say if I order something on abc.com as a prepaid order where I'm paying the amount before getting the product, so what if the product is not delivered? So there's a trust issue from my side. But what if abc.com is a trusted company, but not the delivery service? So let's say XYZ is responsible to take that product from ABC and deliver it to me. What if they are doing some fraud? And so ABC will also pay them, right? So when I pay, let's say $100 for a product, out of which maybe there will be some commission which these people will be getting, right? The delivery company. So there's a trust issue between three different parties, right? From my side to ABC, from ABC to XYZ. Okay, XYZ should trust me, right? Because I belong here. So to solve that problem, we can use smart contracts here. So what if the entire payment system will be automated? Example, I will buy something from abc.com, which will be prepaid, but then ABC will not receive that money. They will receive the money only when I receive the product. So it is that, it's something like if then, right? So in programming, we do that. So if you can implement that programming in that system, in that supply chain management, that is smart contracts. So I am paying, but then it is not received by ABC. It will be received only when I get the product. XYZ will receive the commission from ABC only when they deliver the product, right? So that's the smart contracts. In fact, we can use this not just for supply chain management, but also for, let's say if you buy a car, we have a lot of middle person, right? So we have a dealer, we have a finance company in between who will give you EMI options. So we can automate those stuff as well. There are a lot of legal stuff going on. So smart contracts is efficient when it comes to all this process, making it fast. So there are certain benefits of this. It is fast, it is secure because we're using blockchain here, and it builds trust, which is very important. So not just Amazon, Flipkart, but all these companies, all this e-commerce company, if they can implement smart contracts, people will trust them, right? Because trust is the issue here. So that's the smart contracts. In simple terms, smart contracts are line of codes which you run on Ethereum network, but basically they are built for contracts. What's wrong with blockchain? If you see from the first video, we are talking about good things about blockchain. Not just on this channel. If you go on YouTube, search for any blockchain video, they will talk about amazing stuff you can do with blockchain. But as with every technology, blockchain has some drawbacks. Yes, there are list of drawbacks we can go for, and in fact some people focus more on those drawbacks instead of focusing on the things it provides. But in this video, let's try to focus on 4 drawbacks which is there in blockchain. Welcome back everyone, my name is Naveen Reddy and let's get started. Now when you say blockchain, blockchain has multiple types, out of which the famous one is public blockchain and private blockchain. So the drawbacks which we are going to talk about is more for public blockchain than private blockchain. Again, till this point we have not talked about private blockchain and how that works. We are only focusing on public. Now when you say public, we have some examples, right? We have Bitcoin, we have one of the famous one which is Ethereum, we have EOS. So the first drawback is blockchain is complex. May not be the technology but the terms itself. So the moment you start learning, yes, it is exciting, it's amazing. Problem starts when you try to understand those terms. We have consensus, we have chain, we have nodes, miners, So all these things actually create a lot of confusion initially. Yes, the moment you start working on them, it will make the concept clear. But initially it is complex. The technology itself is damn complex, right? Because you don't have a central server, you have multiple machines, you have to provide coordination, there are different algorithms available. So in general, the concept of blockchain is complex. But when you start working on it, a lot of things will get clear. The second drawback. Now when you talk about public blockchain, example, Bitcoin, we have Ethereum. The problem is, this technology promises that they will replace banks, they will replace all the credit cards and debit cards. Now think about this, when you talk about Visa, Visa can handle thousands of transactions per second, okay? And that's amazing, right? Every one of us use Visa card and we know how fast it is. On the other hand, when you talk about Bitcoin, Bitcoin uses proof of work as the algorithm for consensus. And it can process around 7 to 10 transactions per second. Now think about this, if you say Bitcoin technology will replace the credit card, you have to wait. So the moment you use Bitcoin there, you have to wait for some time, right? Because we have millions of people doing transactions every day. So we have to handle that, right? So Bitcoin cannot handle that speed. So the second drawback is slow. Okay, I'm not talking about private blockchain here, I'm focusing on public. So public blockchain is slow. Now the third one. Now let's only focus on Bitcoin and Ethereum because Ethereum still uses proof of work. Now the moment you talk about Bitcoin and Ethereum, they are using proof of work, right? And we all know how much energy it consumes to solve a given puzzle, because not only one node will be doing it, right? We have thousands of miners and everyone is solving a given problem. And the puzzle is a waste of time, right? Because the main thing is transaction. We have to add the block of transaction in a blockchain. But for that, we have to do 10 minutes of work, which will consume huge amount of resources. We don't want that. We don't want to waste resources. So that's the third drawback of blockchain. Let's go with the fourth one. The fourth one is security, or you can say privacy. Now think about this. When you talk about Bitcoin, which is a public blockchain, the moment you say public, it means the blockchain is available for everyone. Anyone can see the blockchain data. Oh, that's scary. So let's imagine Naveen is sending 10 Bitcoins to Rahul. Now in this case, everyone knows that Naveen is sending 10 Bitcoins to Rahul because that data is available in public blockchain. See, we have the advantage that the data will be there in the blockchain, so no one can change it, but everyone knows how much Bitcoin I have sent to Rahul. But Bitcoin says, hey, you don't have to worry about that because we will not be storing Naveen and Rahul in the blockchain. Yes, the 10 Bitcoins will be there, but then Naveen and Rahul will be having a different address. And that address will be anonymous. So no one knows who is exactly sending data to who, right? But they know that some address is sending data to some address. And I know that some address is me, and Rahul knows that some address is this guy. So that's how it works, right? So it is still anonymous, but the data is there on the blockchain. Maybe if you have a company data which is confidential, it will be available in public blockchain. Everyone can see that. Maybe who has sent it to whom is not there, but the data is there in the blockchain, right? So that's one issue with the public blockchain. Okay, and the fifth one, which is very, very important. Now, it is also a part of security. Now, everyone says, right, blockchain is immutable, no one can change it, and we are safe. Now, we are saying it is safe because let's say if you have a blockchain and if you have 10 miners, now these 10 miners are responsible to handle the blockchain, right? They will maintain the state of it, we'll be using different consensus algorithm here. But what if we have one malicious node? Okay, the moment you say you have one malicious node, the remaining 9 will say, hey, get out from the network, right? Because they have the power, they are the majority. But what if you have 6 nodes which are malicious? That's where the problem starts, because majority wins, right? And that's the one of the issue we have in the blockchain, that is 51% attack. So if you have more than 51% of the nodes which are malicious, and if you have the power to it, they can attack blockchain. And yes, blockchain can be hacked if you have 51% strength. So these are the drawbacks of blockchain. Yes, we have to focus on the benefits, but it's good to know the drawbacks as well, right? And it will be useful when you debate with some people, because there are people in the world who are saying blockchain is worst because of these drawbacks. You can focus on benefits and they will focus on drawbacks, doesn't matter. So what's important is blockchain is awesome, keeping this thing aside. But don't worry, the drawbacks which we have talked about is for public blockchain, right? On the other hand, we also have a private blockchain, and that will solve this issue. In this video, we'll talk about Hyperledger. Now, in the blockchain world, we have heard so many concepts, right? We have talked about Bitcoin, we know the concept of Ethereum, and then now we have something new, which is Hyperledger. In fact, the amazing thing is, it's been only 3 years and it is so famous. All the big companies, maybe Intel, IBM, they are putting their hand in this project. So what is Hyperledger? Now, as per definition on the official website, it says Hyperledger is an open source collaborative effort created to advance cross-industry blockchain technologies. It's a global collaboration hosted by Linux Foundation, including leaders in finance, banking, Internet of Things, supply chain, manufacturing, and technology. Now that's a big definition, right? So to understand it better, we have to understand what Hyperledger is not. First of all, Hyperledger is not a blockchain. It's not a company. It's not a cryptocurrency as well. Now Hyperledger is a project. So what happened, when you talk about public blockchain, we have Bitcoin and we have Ethereum. Now this works because of it is public, and then we use a cryptocurrency concept as well. Yes, there's a big debate, should we use Bitcoin or not? But the thing is, blockchain technology is solid, right? Everyone wants to use it. Now till this point, everyone was thinking about we can use blockchain or we can use cryptocurrency to change the market. But they were talking about B2C, which is business to consumer. But what about B2B? What about enterprise market? And of course, right, even enterprise market, you want to use blockchain. How they will use Ethereum? The problem is, the moment you talk about Ethereum or Bitcoin, they are public blockchain, not secure. The transaction is slow. So there are so many issues with public blockchain. To solve that problem, we got this project, which is Hyperledger, and this is hosted by Linux Foundation. Now, if you don't know about Linux Foundation, I would recommend you to go to Google and search about it. There are so many technologies which are part of Linux Foundation, and just because of them, we are using all these amazing technologies, including Hyperledger now. So Hyperledger is new, but then in just 3 years, Hyperledger got so many members from different fields, maybe banking, technology, aviation, supply chain. Now, all these companies came together and they are working on open source projects. So you can imagine Hyperledger as an umbrella or a greenhouse for blockchain open source products. Now, since we have talked about projects, Hyperledger literally has multiple projects. Now, you can divide into 2 parts. We have some frameworks and some tools. Now, if you talk about frameworks, we have this number of frameworks available, and the most famous out of this is 2, in fact, one from Intel Sawtooth, and the second one is Fabric. Fabric is one of the popular Hyperledger framework. Not just framework, we also have tools available. So you can use these frameworks and tools to make your blockchain. Now, specifically, this can be used to make a permissioned blockchain, or you can say private blockchain. But then we can also use them for public blockchain. So that's the introduction of Hyperledger. So let me repeat, Hyperledger is not a blockchain. It's not a cryptocurrency. It is something different. It's a project in which you have different frameworks using which you can build blockchains. And in this video, we'll talk about smart contracts. In fact, we'll be writing our first smart contract. So we will be doing this in 2 videos. The first video, we will try to set up the environment. Of course, right, if you want to write your smart contracts, you need a network, not a normal network, but an Ethereum network. So we have to connect our machine with the Ethereum network. That means you have to create this machine as a full node. Oh, that will be a difficult task, right? So anyway, we have to connect with the Ethereum network, or maybe a test network. Again, we'll discuss why do we need a test network there. So we'll do that first. Then in the second video, we'll write our first smart contract, not the difficult one, a simple one, because we have to understand how do you write a smart contract. So let's get started. So the first thing you have to do is we have to set up this machine so that you can connect with the Ethereum network. Now in Ethereum as well, if you want to connect with the Ethereum network and if you want to do transactions, you have to pay some gas fee. Okay, now what is gas fee? So whenever you do a transaction, of course the miners want to get rewarded, so you have to pay a transaction fee, and normally we can call them as gas. Okay, so that means before doing any transaction on the Ethereum network, you need ethers. You have to buy ethers, and then they are damn costly to buy now. So what to do? We don't want to buy any ether because we are learning what is smart contract. So in this case, what you can do is you can work on test networks. So on the test network, it is not a main network, so you can use the test network here. And the advantage is you don't have to pay to do the transaction because we are learning. So of course, if you want to do real transaction, you have to move to the Ethereum network, not on the test network. Now, what are the test network options we have? But before that, we have to understand how do you connect this machine to the network. It doesn't matter is it a main network or a test network. Now, first of all, we have a browser here, right? And browser normally works with the centralized systems which we have. But what if you want to connect your browser? What if you want to make your browser as a distributed app? In this case, you have to use an extension. So you can see we have a browser here, which is Firefox. You can use any browser if you want, Chrome or Opera or Firefox. You have to add a plugin. Now, which plugin I'm talking about? This one. So we have to add a Metamask plugin or the extension. Okay, so you can see this is Metamask, this is the official website, and it says bring Ethereum to your browser. And that's a nice tagline. So we can add add-on on Firefox or on Chrome or Opera. In fact, we have this amazing new browser, which is Brave browser, which I'm trying out now. I'm using it from quite some time now. This is good. You can also try this. And there's some information we have. So it's Metamask is a bridge that allows you to visit the distributed web of tomorrow in your browser today. So that's an amazing lines they have. But the idea is you can build the apps and you can deploy them with the help of this. Okay, but how do we add the plugin? So as everyone knows, you can simply go to here and you can search for add-ons. So we have to go to extensions and we have to search for Metamask. It will take you to it will search for all the thing, and you can see we got a Metamask plugin here or the extension. Just you have to click on add to Firefox. It will take some time, and then you have to click on this add, so it will add the extension to your browser, and you can see we got Metamask here. So it says welcome to Metamask. So let's continue with this process. So let's say get started. Now this is amazing. It says new to Metamask, and the answer is yes. So for us, we are new to Metamask. Yes, I have a Metamask account as well, but let's do it fresh. So you can see on the left hand side it says no, I already have a seed phrase. You can import your wallet. So I have a Metamask on the other machine. I can simply import the ethers which I have on that machine. So you can click on import here if you have a Metamask account initially. So if you have it, it will ask you for 12 word seed phrase which you have to click. So they will give you option, you have to click on that. Since we don't have it, so we click on create wallet. So it says help us improve the Metamask. We don't want to do that now. You can say I agree. Let's do that here. You can still say no thanks, but let's do that. Now it will ask you for the password. Let's keep it simple. I will use my password here. Then we have to click on create. Let's just save the password for me. And you can see this is very important. This is a secret backup phrase. Now this phrase is very important because we don't have a concept of, it's a two-way verification. So password plus the phrase. You can use this if you want to import the wallet or something. Now I will not be clicking on this for you. So I will be pausing this video. But you will get a text, okay? So you might get 12 words. You just have to remember the sequence of those words. Okay, so I got those words here, and then you can see below we got these words. So those are blurred because I don't want to show you my phrase because it is different for everyone. You know, you have to choose those things in a sequence format. So that's very easy thing, right? So let me just do that quickly. And then once you are done with this, you can simply click on confirm, and that's it. You got your Metamask account. Click all done, and you can see we are connected with the main network. So that's done, right? This machine is connected with the Ethereum main network. How do you confirm that? You can see we have it here. It says main Ethereum network, and this is your account details. So this is your public address. You can simply copy this. That's your address basically. You can also click on details. This is your QR code which they give you. The amazing thing is we have this amazing website which is etherscan.io, where you can track all your activities by using your address or some other details. Let's click on this. We account on Etherscan. And you can see this is a fresh new account. We don't have any transactions. So that's great. So this is the current price of Ether, I guess. So let's go back here. We don't want to do that. Now, how will you get some money? Because we want some Ether, right? You can see we got 0 Ethers here, so you have to buy it. We don't want to do any investment now. So what you will do is, instead of working on the main network, we can actually work on these test networks. Out of all this, let's go for RinkeBy test network. Let's click on this. And still I got a 0 Ether. That's bad. We don't have any Ether here. So how do you get Ethers here? It's very simple actually. You can see we have an option of deposit. When you click on this, it will say, I want to go for test faucet. Let's use it for test. So I will say get Ether. Okay, do you have to pay? Not exactly. So you can see it will show you, it will go take you to the website. It has some data here. We don't want this. Let's click on this crypto faucet. So this is how you will get your free Ethers basically. So it says if you want to get the Ether, you have to share your address on the social network. It can be Twitter, Google Plus, or Facebook. I guess Google Plus is not running anymore. So it is Twitter and Facebook. So let's use that. So I use Facebook a lot, so let's do that. Okay, so what you do is you just have to copy your network address, and you can see for me it's here. So copy, that's my address, and then I have to go to Facebook. So that's my Facebook account. What I will do is I will say I need some Ether. You can type anything you want, okay? They don't care about your text. What they care is about your address. So let's do that. In fact, I will keep this post for you, so you can just go to my Facebook and you can check if I have that post there. So that's my address, and I will click on share. So I'm sharing this on Facebook. Let me just get the address of it. One way I know about this is how you can get the post address. So you can see we got the address on the bar. So that's the address. Let me just copy it. Go back to your RinkeBy, and this is where you have to paste it. So let's paste it and click on give me Ether. So I want let's say 18 Ethers for 3 days. Click on that. Oh, now it's time for capture. It looks like I got my Ether. Let me just go back to my RinkeBy, refresh. Something is not working here because yesterday itself I got some Ethers on my different account. So maybe on one account they provide you Ethers only for that particular days. So I've asked for 3 days Ether there, so it is not working here. So what I will do is once this video gets over, I will import that here. But then this will work. So you try it out, you will get some Ethers here. This is how you set up your Metamask, and you will be getting some Ethers as well. You will be getting approximately 18 Ethers. You can use that. So you can try it on any network here. You can use RinkeBy or Robston. So you can just try it out. Now once you got your setup, once you got Metamask, the next thing is how will you write your code? Of course, we want to write our code somewhere. So there's an amazing website you can use here, which is, so when you search for Remix Ethereum, this is the website you have to go to. It is a Solidity IDE which we want. We want to write our Solidity code, right? And you can say this will give you a code here which we don't want. In fact, in the next video, we will write our first smart contract, and we will be creating our first SOL file, which is Solidity programming. So this is where you can add new files. You can see they have 2 files here. We will delete this and we'll create our own. So that's how you do the setup. You need a MetaMask because you need Ethers. You need a way to connect with the Ethereum network. And the second thing, you need IDE. So we are using Remix, the online IDE for Solidity. In this video, we'll write our first smart contract. In the earlier video, we have talked about how can you do the setup for MetaMask, and then how do you get those Ethers. Now there was some issue with the Ethers we have not received on this machine, but if you have tried the same steps, you will receive some Ethers. The problem was 2 days back, I have asked for the Ethers with the same Facebook account. Maybe that's the issue. So now I did with Twitter, so I got 3 Ethers, I guess. So if I go to MetaMask, you can see we got 3 Ethers, and that too on RinkeBy network. So that's great. Let's use that. Okay, so let's go to the Remix IDE, and you can see the font is not that visible. First of all, I will delete these 2 things. We don't want their code. We want to create our own. So let's do that. And you can see it's clean. So we got a clean slate. It's just that how do we increase the font size for this? Oh, there's a way here. You can see plus sign, and you can now I think it is visible. Let's create our first file. But then what we will be doing in this? Let's mimic a bank balance or bank account. So what you do in bank account is you add money and you withdraw money. That's what we want to do, a simple task. So we'll be having a bank account where we'll be having a balance, and then we might add a balance, or we might withdraw the balance, or we can say deposit or withdraw. Let's do that. So let's create our first file. So we'll click on plus here and we'll give the name as, let's say, bank.sol. So SO is for SOL for Solidity. Let's click on OK. And you can see we got our file here. We can type a code now. Okay, so what to do? Now, first of all, we have to set a compiler level. Now, this compiler level here. As we get new updates for Solidity, the syntax might change. We might get some new features. But let's stick to the older version of compiler, which always works. And then how do you decide that? So the way you can do that is by saying pragma. And then we have to mention the language name, which is we are using Solidity. And then we have to mention the version number. If I go back here, you can see we have a list of compiler we can use from. We have 5.0.7. All this thing will work, but let's stick to those things which everyone uses nowadays, which is 0.4.25. So let's mention that 0.4.25. Okay, so we have defined the compiler level now. The next thing is we have to write a contract. That's what we want to do, right? But then what will be the syntax of it? Now, first of all, Solidity is derived from JavaScript. So if you know JavaScript well, this is damn easy. Even if you know Java, it's almost same as creating a class. So let's go with those steps. So let's create our first contract. So let's say, if you want to say contract, you have to say contract. Then we have to mention the name of the contract. So in this case, I will stick with bank. Let's create a contract for bank. Or we can say bank transaction. There's no need to have a same name as your file name here. We can have any name, doesn't matter. Okay, now we need a variable. Now, why do we need a variable? So variable is a place where you can hold data. Now, first of all, if you say bank, we will be having an account there, and every account will have a balance. So let's say int bal, or we can say balance. Int is a data type, so the balance is of type int. We can also go for double if you have it, if you want that. Let's stick to int here. Now, once we got a contract, once we got a variable int. Now, if you go from Java background or JavaScript background, so I'm assuming that you know at least one object-oriented programming language. It can be C#, JavaScript, Java, PHP, Python. That's your choice. So here what I'm going to do is I want to create a constructor. Again, not compulsory, but let's do that. So what I'll do is I will say constructor. Now, how do we create a constructor in Java? In other language, what we do is we use a class name. But here we have to say constructor, and then we have to give a bracket. We have to also mention the specifier or the access level of this. So when you say public, it is accessible from anywhere. I know that's weird because in Java we write it on left hand side, and that makes much more sense, right? You will get used to it. And let me just set the balance initially to, let's say, 1. So I want everyone to have a balance at least of $1 or 1 rupee, whatever. Okay, so once we got a constructor, we need to create a method. Now think about this. When you say a balance, of course we get an option of depositing the money, withdraw the money, or we want to check the balance, right? So let's create those functions. Now, if you want to perform those operations, we have to get functions. Okay, so 3 functions, right? Let's create that. If you want to get a function, you have to say function. Okay, but what should be the function name? Initially, I want to get the balance. So let's do that. So we'll say get balance. I'm just using camel kissing rule here because I'm coming from Java background. Let's save the function name. And this function will return balance. It looks like a normal programming language, right? We have done this before. So we can simply say return balance. That's one method we have, or function we have. Let's create one more function which is for withdraw. So I will say withdraw. Now when you say withdraw, of course we have to also pass the amount, right? How much amount you want to withdraw. So in this case, I would say int amount. That's my variable name. And here as well, we'll say balance is equal to balance. We are withdrawing, right? So we have to remove the money. So we'll say balance equal to balance minus amount. But are we missing something? Yes, every method or every function need to have a specifier. So we'll say public. And here as well, I will say public. That's done. Now here we have to create one more method which is for depositing money. So I will say function deposit. Again, we have to specify the amount because how much amount you want to deposit. Let's mention public there, which is the specifier. And here I will say balance is equal to balance because when you say deposit, you are adding the money, right? So we'll say balance plus amount. A very simple one, right? But will this work? There are certain changes. The first one is when you say these 2 methods, withdraw and deposit, they are changing the value of your object. Now, when you look at these 2 functions, which is withdraw and deposit, they are changing the value of your balance. That means they are doing some operations there. But what about this get balance? So this get balance is not changing any value, right? So in this case, what you can do is you can mention this as a view. So when you say view, it means this is only for fetching value. This will not be manipulating the data. So we can say view. And then since it also returns the value, what you can do here is we can say returns. We have to also mention the type what it returns. So we have to say returns int. And that's done, nothing more here. There's one more error here which says we have to change it to pragma 0.4. So let's change the compiler number here and we'll set 0.4.25. So problem solved. That was the issue with the newer version. So you can see the older version with 0.4.25. In fact, we'll also use the newer versions in the later videos, but here this one works. You can see there's no compile time error. Now once you have done with the code, it's time to compile the code. That's how you convert your code into a bytecode or a opcode. This opcode will work on your virtual machine or on the Ethereum network. So what I will do is I will say start to compile, and this will compile it. I don't think there's an issue here, or maybe I will simply use auto compile. This should work. I guess it is compiled, there is no issue. Now how do you run this code? To run this code, we have to click on this run tab, and you can see the moment you click on run tab, we have an option here. So you can see environment. The first environment here is JavaScript VM. Now what this VM? So this VM will run on your browser itself. And that's what we said, you can use Metamask to create an environment in your machine itself. So you can see whatever code you are writing here will run on the same machine. Now once you select your VM, you have to also select the file you're working with. So you can see we are working with bank. You might have multiple files here, and then you have to click on deploy. The moment you click on deploy, here you can see we got some options here. When you scroll up, it will mention everything, the hash value from, to, then the gas it requires for the transaction and everything. So you can see we got all details here. Okay, that means your app is deployed, but we have to run this, right? How do you run this? So you can see we have an option here of deployed contracts. Let's expand it, and you can see we got 3 buttons. Out of which this two has the same color because they are changing the value of balance, and this one is not changing the value. That's why it is a different color. First of all, let me click on get balance, and you can see the balance is 1. Oh, why 1? Because the default value we are given is 1. That's great. Let's deposit some money before withdrawing. Let me deposit 100. Click on deposit. I don't know if it is done or not. Let's click on balance, and you can see we got the balance as 101. That's great. Let me just withdraw some amount. Let me withdraw 80. Okay, first you have to click on withdraw done, get balance 21, and if you can see, everything is happening so fast because everything is happening in your machine, not on the main network. The moment you do that main network, it will take some time. Okay, so here you can see every time you fetch the balance, it will do some transaction. And one more thing, every time you do some calculations here, example, if I add 400, if I say deposit, it is consuming some gas. Okay, it is charging some gas. The only thing is, in your machine, it is your environment, you're the boss. That's why everything is working. And in this video, we'll continue from where we left in the last video. So in the last video, we have talked about the smart contract, right? In fact, we have written our first smart contract, and then it was running on the local JavaScript virtual machine. So if you look at the environment, we have JavaScript virtual machine, and then we were getting some addresses. We got some 5 address, and then we can use any of it to deploy the application. And once you deploy it, you can just test it by depositing money or by withdrawing money. But how about if you want to run the same thing on the test network? So I don't want to run this on the JavaScript VM because that's a local. We want to run that on a test network or maybe on the main network. So if you want to achieve that, we have to use injected Web3. The moment you select that, you can see the default option which I got here is RinkeBy. Why? Is because in the Metamask, these accounts are actually getting fetched from the Metamask, right? So if you expand this Metamask, you can see we have RinkeBy test network here. Let me switch the account. So you can see this is RinkeBy test network, and I have 3 ethers here. I can use this for the transactions. In fact, you can also move from RinkeBy to main network. The moment you do that, you can see it will ask you for the reloading of the page. So let's reload the page, and here, okay, it's done. Let's go back to run, and you can see in the Web3, if you select inject Web3, you got 1 address because this is your main network now. So that's how you can switch. So you just have to switch from Metamask. That's the only option you have. So go back here. We don't want to work on main network because we don't have the currency. So let's switch to RinkeBy test network. Let's reload it. Yeah, that's the inject Web3. And let's select the account. So you got only 1 address because I only have 1 account. I guess I have 2 accounts, but you can select which one you want. Okay, now I want to deploy this on a RinkeBy test network. So if you want to achieve that, you have to select the code we are working with. We are working with bank. Let's click on deploy. The moment you deploy it, it will be done on the test network, right? Which is running or as an actual network. So of course you have to spend some ethers. Okay, you're not buying those ethers, by the way. We are using the free ethers, if you remember. So we have to spend those ethers, even for deployment. So when you deploy it, you have to pay the ethers. But then every time someone else is using your network, they will pay for the ethers. Every time they do transaction with your application, they will be paying for the gas fee. So here, the moment you do that, it will pop up the Metamask notification. We will say, okay, I confirm this. Let's click on confirm. And you can see it will get deployed on this address. So let's click on this address here. It will take you to etherscan.io, and you can see this is a test network. So you can see the moment you do that, it still says it is pending because it takes some time for it to get mined. I guess it is done. Let me just refresh this page. You can see it is success now. So initially it was pending, now it is success. You got, this is the address from to, you will see all the details here. That's your block number. Anything else? This is your hash. Let's go back to Remix, and you can see it is deployed. So this is your deployed contract. So let's go back here and we can perform operation. Get balance will not charge you anything. So you can see balance is 1. That's what we have done in the code. Let me just zoom a code a bit. So you can see that's 1. That's your balance. But if I want to deposit some money, let's say I want to deposit 300. The moment I click on deposit here, again it will charge you, right? Because you are doing a transaction which will change values. So you have to pay the gas fees. So you have to click on confirm. So this is important, right? It will give you a notification. But in case if you have notification blocked in your browser, sometimes it happens with me as well. So you have to just go here and it will show to confirm or not. But since it is working on my machine, I will do that. So I will say deposit, I will say confirm, and it should be done. Again, it takes some time. You can see if I say get balance now, still the balance is 1 because it takes some time to deploy. So you can see we got the confirmation now. So let's click on get balance, and you can see it is 301 now. You can also do withdraw. Let's say I want to withdraw 101. Let's click on withdraw. Again, as you can guess, we have to pay for the gas fee. Let's do that. Okay, again, it will take some time. Let's verify if it is still pending or done. So you can see it says it is pending. You will get this link in the console. Just click on that and you will see this page. In fact, your browser will also give you notification once it is confirmed. So let's wait. Okay, so when you click on get balance now, we got 200. So that's how it works. That's how you can use your test network. The only thing is we don't want to spend money on the main network, and that's why we are using RinkeBy. But the same thing will work on the main network if you configure that. So just go back to MetaMask, switch back to main network, buy some ethers, and you're good to go. And if you can see, initially we were having around 3 ethers, and now we have 2.9998 ethers. So yes, we have spent some ethers here. So that's how we can use RinkeBy network to test the application. So I hope you got some idea in this video how do you work with RinkeBy with your remix. In the next video, we'll do something amazing. In fact, in the next video, we'll try to connect the front end with this blockchain. So when you say front end, the normal web page, maybe a simple web page which will connect with this blockchain. In this video, we'll try to connect the smart contract which we have done before with the front end. So when you say front end, it can be a normal web page or it can be an Android application. But as of now, just to keep it simple because Ethereum supports that, let's stick to the web page development. So we will create a simple web page and we'll try to connect that to a smart contract. But why? Now think about this thing. When you say blockchain will be replacing a lot of different technologies, right? Companies are moving from the centralized system to distributed systems. So yes, it is changing a lot in terms of enterprise network. It is changing in terms of currency market. But what about normal companies? So let's talk about Facebook. So if you think about Facebook, Facebook has a server, right? As a user, what we do, we access those pages. So on our laptop, we see a screen, which is maybe a login page or the messages page or the feeds. And then those data is actually coming from the actual server. So whatever processing is happening is on the server, right? But the amazing thing is, as a user, we don't even know what technology they are using in the backend. Are they using Node.js? We are not sure. Are they using PHP, Java, ASP? We don't care. What we care is, as a user, we are able to access our data. Now, even if in future, Facebook is changing that technology, the centralized application, to a distributed system, will it affect us? That's the question. Because the moment you change the servers, the moment you talk about, all the processing will be done on smart contracts, on blockchain. So as a user, do we get the same page or a different page? That's the question I was having in my mind from a long time. And the answer is, you will get the same page because the front end will not change. Only the back end part is changing. So in this example, I will try to prove that. So whatever we are doing here, so if you see this smart contract, what we are doing is we are trying to withdraw the money, we are trying to deposit the money, we are trying to get the balance. But then we are able to access those functionality with these buttons, right? But think about a normal application. As a user, you want to access a web page where you will do all this operation, not on this type of screen where you can see the code as well. So I want to create a separate page where I can see this. Let's get started. So the first thing you need is you have to understand certain terms. The first one is if you go to compile, we have a concept of ABI here. And if you click on details, you can see we have ABI. And this ABI has certain JSON codes. If you can see that. This is basically a JSON code when you expand it. So we will need this thing when you want to connect your web page with the smart contract. So we require two things. The first one we need is ABI. And the second thing we'll need is if you go to run, this address. I have deployed it in RinkeBy. So if you have not seen the previous video, I will suggest do that because we have created a smart contract. We have connected with this RinkeBy test network. So we got this address, right? So this address is important. So we need two things, the ABI and this particular address. Now, once you have that, let's get started. Oh, before that, we need one more thing. In fact, we need certain things. We need a good IDE. So you can use any HTML IDE you want. You can use Visual Studio Code, you can use Atom, you can use Sublime, that's your choice. I'll be using Visual Studio here, so let me open VS. So that's my Visual Studio Code. So if you don't have this IDE in your machine, in fact, you can use any IDE you want. You can also use Eclipse, NetBeans if you have. You also need a server because we will be running the page, right? So we got a Visual Studio Code. If you don't have it, you can simply go to Google and search for Visual Studio Code download. And this is where you will get the setup. This doesn't matter, is it Mac, Linux, or Windows. It has all the options. Not difficult, just say next, your work will be done. So once this is done, the next thing you need is NPM because see this, when you type the code, you also want to run it, right? So you want to run your HTML, which will be also having jQuery. So if you want to run that, you need a simple server where you can host it. You can also have a web server on the web server, the actual web server, or you can also have that on your local machine. So you can use different servers available. We have Light server, we have HTTP server. So you can install HTTP server here, but then for that, I'll be using NPM. So install NPM. So you can just go here and search for NPM download, and you can just go here, you can download it, depend upon which OS you have again, and easy setup, nothing to worry about. The only thing is, once you have downloaded it, just go to program files, go to that software, NPM or node, copy the path and go back to your environment variables and set the path. I hope you know how to do that. It's very simple actually, you can just Google it. Now, once you have your Visual Studio and NPM ready, let's install the HTTP server. So go back to Visual Studio. Now, how do we install this server? So we can use NPM, right? And then I have also set the path. Make sure that after setting the path, restart your Visual Studio. So just click on terminal, click on new terminal, and this is where you will see the terminal area. Now, based on what OS you're using, if you're using Mac or Linux, you will see terminal, the actual terminal. This is a command prompt, which we are there calling terminal. Doesn't matter. In fact, before opening terminal, make sure you create a folder. So on your desktop or in documents, make sure you have a folder where you will put this file. So I do have a folder. I've created a folder which is bank web app, a blank folder, empty folder. So you can see I have a folder which is bank web app. Just select that. You can see it's empty. Now, once I got this folder, in this folder, I want to create a page, right? So we'll do that, but then you can see we got a terminal. So I wanted that path here. So I don't want to go there manually. So we got a path, we got a folder. This is where you will write the code, right? This is where I want to install HTTP server. So I will say npm install. So I want to make it globally, and the software name is HTTP server. Let's say click. Now, the amazing thing is I do have this set up, so it will take less time. For you, it might take more time. So once you got your HTTP server, the next step is you have to start it. So the way you do that is by saying HTTP server. The moment you say enter, it will take some time, and you can see your server has started. And it is started on this URL, which is localhost:8080. So In order to access that, just go to your browser. I will say localhost colon 8080. Okay, you can see the server is running. That's your node server. But I want to replace this with my page. So let's go back here and let's create a simple file. Click on this and I want the file name to be index.html. You can have any file name, doesn't matter actually. And let's get started. The first thing you need is HTML tags. The type of UI we need a text field where you can enter the amount, and then you will be getting buttons like withdraw or deposit. I had this code with me, so just pasted it here just to save time. So you can see we got an input text field, and then we got p tag where we can show the balance, and then we got two buttons, deposit and withdraw. Now once you have this body with you, it's time to perform operations. So let's see if this is coming as a normal text. So if you refresh now, you can see we got a different UI. In fact, the balance is empty, that's why you can't see anything. But you can enter some values and you can click on deposit. Nothing will happen because we have not coded it, right? So we will click deposit. It should be deposited in the actual smart contract which we are running, this one, and then we can withdraw from that. So let's do that. But then we will be performing operations on the buttons, right? So that's why we need to work with jQuery. So that's one thing. Second thing is, how will you connect your web application or your web page with the Ethereum blockchain? And that's where we got this amazing library named as Web3. So if you can just go to Google and search for Web3. So this is the Web3 GitHub link, and they have the notes as well. So you can see it's an API between the Ethereum blockchain and your web application, so we can use it. In fact, you can also install this on your machine using NPM, or we can use it as your JavaScript library. So in this example, I will use the JavaScript library which they provide. In order to do that, what you can do is you can say download web3.js. So when you click on download, it will take you to the link. You can download it from there. Or in fact, there's also issue with the proper version. You know, we have to go for 1.0, or we will be going for developer version. So that's one thing. Otherwise, what you can do is I will provide you the link. CDN for the Web3, you can use that because that is working. I don't know, this was not working when I tried it. The download, maybe there was some bugs. You have to, maybe when you are trying it, it will work because they are always doing some updates, and there might be some bug when I tried it. You can try my link, which is working. So let me add those two scripts, one for jQuery and one for Web3. So that's done. I have added two scripts here. One for, you can see one is for Web3 and second is for the jQuery. Now, once we have done that, we need to perform certain operations now. The first one we need is, the moment you load this page, I want to show the balance, whatever balance is there in the blockchain, right? In fact, let me just check once what is the balance I have there. So if you can go here and if I say get balance, so the current balance is 200. I want to fetch this. So how do we do it? The first thing you need is a script tag. So I will say script, and inside this script, now if you want to connect with a contract, the smart contract, let's create an object which will hold it. So I will say contract, and then I want to fetch the contract details only when the page is loaded. And the way you do that is by saying $document ready. So whenever it is ready, let's perform the function. Okay, let's perform the operations here. So what we need, whenever your page is ready, I want to first create the object, or I have to initialize the object of Web3. Okay, but then from where you will get this? So in fact, the syntax is very simple. It's Web3 is equal to, we have to say new Web3 because that's how you instantiate the objects. And in bracket, we have to specify the current provider, because we are using Metamask, which is connected with the RinkeBy. So that's our provider, right? So let's use that. So I will say web3.current provider. Now depends what you are using here. So if you are using injected provider, you can use this. In fact, if you see, we have other options as well. So if you click on this, you can see we have one more option of web3 provider. That's where you can use Ganesh as a CLI. But as of now, let's stick to current provider. Now this object, which is Web3 here, that's a confusion part, right? We have our object initialization here, and then we are creating the object. So this Web3 is actually coming from the library which we have used above. Okay, now once we have done this, the next thing we need to initialize is the contract, right? We are already using contract here. So we have to initialize this particular object. And the way you do that is by saying new. We have the object which is Web3. In this, you can simply say it, which is Ethereum, and then dot, you have to say contract. That's how you create the object. So contract is a class of which you're getting object here. But unfortunately, or fortunately, this contract will ask you for two parameters. Now if you remember, we have talked about this before. You need ABI and you need the address. Of course, right? Which smart contract we are talking about? So this particular application will work with our smart contract. So you have to specify two things, the ABI and the address. So what I will do here is I will create two variables. First variable I will say address, but from where you will get this address? So I will be getting this address from here. So go back to a smart contract, just copy it. You can see we have an option of copy. Go back here and say paste. So that's your address. The next thing we need is ABI, and from where you will get the ABI, so you will get it from here. So go back to compile, details, and you can simply click on copy here. You don't have to exactly expand this and copy. Say copy, go back here and paste before the semicolon. And I guess our job is done. Now I should be minimizing it so that it will not waste a lot of lines. So yeah, you can see we have address and we got ABI, and we just have to pass it here. So the first thing you have to pass is ABI, and the second thing you have to pass is address. Done. So we have done two things. ABI is done, address is done. Now what next? See, once we got the contract object, now we have to fetch the balance in the contract. How will you do that? So in order to do that, we will be saying contract dot. Now this contract will have certain methods, right? We have three methods actually. So let's say methods dot. So if you want to fetch data, the method which we have used here, if I go back to code, so the method name is get balance, right? We have to call this method. So I will go back to methods, I will say get balance. Now this get balance, if you want to call it, there's a method which is named as call because you're calling it, right? And you're expecting a value. So you will say call, and then here, actually this call will return you a promise. And if you want to fetch the value, if you have to say then, and then whatever value it is returning, it will go into a function. This is basically a JavaScript code. So I'm not here to explain JavaScript. If you want to know more about JavaScript, just go to this channel. We have a JavaScript playlist, just watch that. But here the idea is this will give you a promise, and if you want to fetch data, you have to say then, and in this function you have to say, you can use any variable. I will say balance, whatever variable name you can use. Okay, so in this I'll be fetching the balance, right? So once we got the balance, we will assign that to this particular ID, which is balance, right? So if you want to do that, you will just come here and say dollar, let's fetch that particular ID, and the way to do that is by saying hash balance.html, and in this you will pass the balance. That's it. That's the only thing you have to do. Once your page is loaded, you just want to fetch the balance, right? That's what we wanted. Just save this. I hope this will work. Otherwise, we have to debug the application. That's what we do always. Let's refresh this page and something is happening. Can you see that? We got 200, right? That's an amazing thing, right? Let's inspect element. Let's go to console and let's see what is happening there. So I will go back here. I will say refresh. You can see there's no error and you got your 200. So that's great. This value is actually coming from the blockchain or the smart contract. So this is working, but what about depositing and withdrawal? So let's say if I say 300, if I click on deposit, I want this 200 to go to the smart contract, save the data, add a block in the blockchain, and then the value here it should be 500. How will you do that? That you will see in the next video. Let's complete the code which we have started earlier. So till this point, what we have done is, if you go back here, you can see whenever you try to refresh this page, it will fetch the balance from the blockchain. So we have a smart contract here, and the current value, if you can see, if I say get balance, it is 200. But what I want here is if I go back and if I say, hey, I want to add another 300, so I want to deposit that money, it should work, right? So if I go back here and if I say, hey, get me the balance, it should say 500. But how do you do that? So in order to achieve that, we have to go back here. In fact, in the smart contract, we have a method which is deposit. So the thing is, whenever you click that button on the front end, so when you click on this button, I want to call this particular method here or function here. So in order to achieve that, we have to make that particular button work. So the button name here is, the button ID here is deposit. So we want to perform the operation when you click on this one. And in JavaScript, if you want to achieve that, it's very simple. You just have to say dollar, and the ID here is deposit. So we are clicking on that button, so we'll say click, and then when you click on this, it will perform a function. It will call a function. So we'll say function, and in this function, let's do that operation. So whenever you click on this button deposit, it will call this particular function. Now in this function, what we want is, first of all, we want to fetch the value which is entered in a text field, right? If you remember, we have a text field here, which is a text box here, which is amount. I want to fetch data from that. And of course, we have to save it somewhere. So let's save it in amount. Initially, the amount will be 0. Now, before fetching the value, in fact, we can fetch the value. You say amount equal to. So we'll say pass int, and in bracket we have to pass that particular ID. So we'll say $hash amount, and here you will say val. That's how you fetch the value. We have to also convert that into integer, and that's why we are saying pass int. So once we got the value, once we have converted into a amount, so we got amount, right? But now I want to call a particular function. Now, even before calling a function, we need to get the hold on the accounts. Of course, right? When you say withdraw, when you say deposit, you need the hold on the account. In order to do that, we'll simply say web3 dot, you will say eth dot. So the method name is get accounts. Now this get accounts will give you the accounts, but that will be a promise. And if you want to fetch the value, you will say then, and then you will create a function. We want anonymous function, and this function will get all the accounts. So let's say if you have 5 accounts, it will get all the accounts. But we don't want all the accounts, right? We want only one. So let's fetch that one. So out of all the accounts it will provide you, we want to get the first account. And the way you do that is by saying var, let's get account ACC equal to, and the way you fetch that is by saying accounts. We want the first one, so we can use an array, because normally these accounts will be having an array. So we want the first account here. Now once we got the account, we just need to call our method, which is deposit. Okay, so it's very simple. In fact, the thing is, this is a callback function, so we have to say return contract as the object we have, contract dots, and we have done this before, right? So if you want to call this methods, we have to say contract dot methods dot. The method name which we are working with is deposit. Let's use that, and in this deposit we have to pass the amount. Remember, we have this amount variable here, we have to pass it here. And then instead of saying call, we have to say send. And in this send, you have to also mention the account, from which account you want to send. And so in the curly brackets, you will say from colon, and you will say account, because that's important, right? The account number. And I guess it is done. So yeah, so this one will give you the accounts, and from that account you are sending it. But what will happen when you send it? There should be some response, right? It should return you something. So it will return you a promise. So if you want to fetch the value from that, you will say, in fact, in the promise, you will be having two things. Either it will be success or it will be a failure, right? I mean, errors. So in the success case, we'll say then function. Of course, we will get something. So I will say we got some data, will be a transaction data. So we'll say tx. So once we got this function, now what we want to print whatever transaction happened in the console. So we can say console.log, and here we'll say tx. So I just want to log the transaction, whatever happened. Now once that is done, I also want to go for the worst case scenario, which is catch. What if something goes wrong? In this case, also we'll write a function tx, and this will say console.log, and this will be tx. That's it. So we are sending the request here, we are sending that method, we are sending the amount as well, and then we are accepting the value, we are accepting errors. So that's great. Let's save this code. I think it's done. That's how deposit works. Let's go back to the browser, and here let's say refresh, and you can see that the balance is 200. Let's say 300. I want to deposit that amount, and that's great. Something is working. You can see it is asking you for the permission. That means the deposit button is working. But will it get success on the server? That's important to know. You can see nothing is happening. Everything is hanged. Okay. The thing is, when you do this, the transaction is in the pending state, right? It will go there, it will get the block, it will get mined by the miners, so it will take some time. So we just have to wait for it, and of course you will get your result in the console, and you can see that we got it here. So we got the block hash, block number, we got all the details which we wanted. And now if I refresh this page, look at the balance. We got 500. In fact, you can verify by going to Solidity, and you can say get balance, and that's 500 for you. It's quite simple, right? Now what about withdraw? We want to make that one work as well. So I want to make this withdraw work. So when I say 100, and if I say withdraw, it should remove that amount. In order to do that, we can simply copy paste this, because that's where we are expert of. So let's copy and paste it, and this is where you will say, hey, this is not deposit, this is for withdraw. The amount thing will be same. We need to get the accounts, we need to pass the account. The method name will be withdraw, of course, and I guess job is done. So that was the deposit, and this is withdraw. Almost same code, right? Let's save this and go back to the server and click on, maybe just have to refresh it once, and click on 100, click on withdraw. Okay, so it is asking for the permission. That is Metamask notification, which we love. Click on confirm, Problem solved, I guess. Yeah, so it went to the server, I mean the blockchain, not the server, that's the wrong term here. It went to the blockchain network, which is RinkeBy network, and then we got the mined block, and that's the new block which you got. Okay, but the question is, have you got the updated value? Let's refresh, and yes, we got 400. That's so easy, right? We have a smart contract here, and we created this front end with 2 buttons, deposit and withdraw, and we are able to perform that. And that's the beauty, right? As a client, we don't even know that what is happening behind the scene. Is it Facebook or something? We don't care about it. So that's how you work with this smart contract with a front end. So I hope you are enjoying this series. Let me know in the comment section, and do subscribe for further videos.